Okay, our last video ended with us calculating the right sum for this function, f of x equals x squared plus 1. And we were using 5 rectangles. And we found our approximation for the area under this curve using these 5 rectangles was 1.44. So here's a picture from a Riemann sum calculator from Wolfram. Now, here they give you the actual area to be 1.3 bar. And the area that we got, the approximation, was 1.44. Now, let's see what happens when we double the number of rectangles. Maybe go 10 rectangles. Okay. Now, notice that our estimated area is 1.385 and the actual area is 1.3. So we've gotten closer. Now, this was a right sum. Let's try a left sum. So remember, the left sum when we had 5 rectangles was 1.24. So now we got 1.28. And what we're doing is we're boxing in this area more and more. So let me go back to the right rectangle and let me increase this again. Let's look at 20 rectangles. Okay, so now we've got 1.35 and the actual area is 1.33. See, 1.35, 1.33. Let me double it again. And you can see what's happening. The more rectangles, the less error we have. Now we're at 1.34, getting closer to the area of 1.33. Let me double those rectangles again. See what we get. Yeah, see? You're getting closer and closer. Now notice the estimated area is 1.33961 and the actual area is 1.3 bar. So you can see what's happening here. As we increase the number of rectangles, we're getting closer and closer to the actual area under the curve. So that's a key. That's a key concept to keep in mind as we define something called the definite integral. We're going to talk about what happens when you let there be infinitely many rectangles. So just look at this. As we increase the number of rectangles, maybe do 500. As we increase the number of rectangles, we notice that our estimated area gets closer and closer to the actual area. And notice from the right we get 1.33433. If we go from the left, let's try it from the left. Let's see what we get. From the right we got 1.33433. From the left we got 1.33233. So notice as we increase the number of rectangles for the left sum, as we increase the number of rectangles for the right sum, what we're doing is we're boxing in the actual area under that curve. Well, that sounds a lot like a limit, right? As we approach from the left, as we approach from the right, we're getting closer and closer to the actual area under that curve. So the more rectangles we have, the better our estimate. And what we're going to do is we're going to say, okay, well, what happens if we let the number of rectangles go to infinity? Since it looks like the more rectangles we throw in there, the better our estimate, well, let's just let the number of rectangles go to infinity. So the question is, can we do that? And if we can, we will have found a way to calculate the exact area under that curve.